I was reading about that massive server outage last year and got me thinking, if you design a system that needs, say, 4 separate paths for data to flow, how do you actually know mathematically that you have 4 truly separate paths? It makes you wonder about the ultimate limit of redundancy in any network.
It's such a core question in systems design.
Right. Whether it's road traffic, supply chains, or data centers.
And the answer really is rooted in this beautiful result from 1927, one of the most elegant concepts in graph theory, Menger's theorem.
Okay, let's unpack this. So for today's deep dive, we're getting into Menger's theorem. It's this fundamental insight that, well, it finds this incredible balance, right?
It does. You said it perfectly before. It's about redundancy. The theorem basically says a network's greatest strength is defined by its greatest weakness.
Wait, say that again? Weakness equals strength.
Weakness equals strength.
Yeah.
Guaranteed. Menger showed that in any finite network, the size of the minimum cut set,
Which is the smallest number of things you have to break to disconnect 2 points.
exactly, the absolute weakest point. That number is always equal to the maximum number of fully separate paths you can find between those same 2 points.
Wow. So that immediately gives you a blueprint for resilience. If you know you need 5 secure paths, you just have to secure 5 potential breaking points.
Precisely. Let's dig into the 2 main versions he formalized, starting with the connections, the links themselves.
Okay, so this is edge connectivity.
Right. Think of your traffic analogy. We're measuring how many individual roads or bridges we have to cut to completely sever the connection between, say, your home and your office.
So paths that share no roads at all.
No edges, exactly. Menger states that the maximum number of those paths is precisely the minimum number of roads you'd need to remove to cause that disconnect.
So if a network guarantees 3 completely distinct routes, we know for a fact its weakest point is only 3 edges wide.
You've got it.
But it gets a little trickier when we look at the other measure, right? Vertex connectivity.
It does, a little, because vertex connectivity is about the nodes, the intersections.
Not the roads, but the crossroads.
The crossroads. We're looking for the minimum number of intermediate intersections you have to close to disconnect the origin and destination. And it's important to note, we aren't counting the start and end points themselves.
So what if? What if 3 different routes all pass through one central highway interchange? Does the theorem still hold?
It does, but you have to be looking for what we call internally disjoint paths.
Okay.
The theorem says the maximum number of paths that share no intermediate intersections is exactly equal to the minimum number of those intersections you'd need to remove.
And that duality is guaranteed?
It's guaranteed. And what's so fascinating is that these principles work for everything from a simple map to a highly complex directed graph, like data flowing one way through a fiber optic cable.
That practical guarantee of redundancy is it's foundational. It's why this 1927 insight is so much more than a historical curiosity. It's the basis for modern optimization.
It really is. If we connect this to the bigger picture, Menger's theorem is the pure mathematical cornerstone for so many applied problems.
Like what?
Well, it was later generalized by the max-flow min-cut theorem,
Okay.
which basically takes Menger's idea and adds capacity, or weighting, to those edges. It tells us the maximum volume a network can carry is limited by the minimum capacity of its bottleneck.
So it's not just is it connected, but how much can it handle?
Exactly. And that insight is so universal, it's actually a special case of the strong duality theorem for linear programming.
The mathematical language of optimization.
That's the one.
You know, that deep understanding of capacity and optimal paths is just so key to solving complex problems today, from logistics to software. And speaking of which, if you need help uncovering where optimization, AI training, or automation can make the most impact for your business, check out embersilk.com for your AI needs. They can really help you find those optimal solutions.
It truly shows how these fundamental insights just cascade across all fields.
And here's the part I find really inspiring. Menger's theorem was later extended to the realm of infinite graphs.
Which is just a mind-bending concept.
It is. The core insight, that duality between weakness and strength, was proven to hold true even in networks that are unimaginably vast. It started as the Menger conjecture.
And the fact that such an elegant mathematical truth remains universal, regardless of the scale of the system, it's just a beautiful reminder that structure and predictability can be found even in the most profound complexity.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.